Good morning, everybody. We're going to talk a little bit more about surface area today. But instead of looking at prisms, we are going to look at cylinders. Okay, a cylinder is pretty close to a prism. In fact, you might think of about a cylinder as like a circular prism. If you remember that prisms are named by their bases. If the base is a square, we call it a square prism. If it's a triangle, we call it a triangular prism. If the base is a circle, we call it a cylinder. It's got a special name. So, if you remember, a prism was a solid geometric figure. Your two end faces were similar, or even more than similar, they're congruent. Right? So, if you have a triangle here, you have an identical triangle on the other end. Right? And those are referred to as the bases. Okay, same here with squares, same here with rectangles. Okay, a cylinder is like a prism. It's got two identical circles on either end, and then it's connected by a curved surface. Now, because we got circles and curved shapes, we're going to be using pi. Pi always comes up whenever you have curved things. So remember, we're going to use pi as 3.14. It's not exactly pi, but we're going to use that estimate so that we all get the same answers. All right, so if we think about this in terms of the nets that we looked at yesterday, if you think about taking a cylinder and unrolling it, so like say this is like a can of soup or something, and you cut it down the side and you unroll it. Okay. Well, hopefully you can see that the sides of the cylinder, if you lay it flat, it'll create a rectangle. Right. So think about cutting a soup can in half and unrolling it, it would unroll straight. So you'd have a circle at the top, a circle at the bottom, and you would have a rectangle in the middle. So when we're finding the area of cylinders, we're just finding the area of two circles and a rectangle and adding them together. Now, yesterday we looked at the formula for the area of prisms, which also applies to cylinders. As you may remember, we saw that surface area is the perimeter times the height plus 2 times the area of the base. So if I compare that to what I'm seeing here, I can see where the 2b comes from, right? Because we have a base here and an identical circle here, right? So 2 times the area of the base makes sense because that'll take care of those two circles. Okay, the perimeter times the height. Okay, if you think about this rectangle right here, we're dealing with a circle. So we have a fancy name for the perimeter of a circle. The perimeter of a circle, you might remember, is called circumference. Okay, if you think about this, like I mentioned before, cutting this down the side and unrolling it, hopefully you can see that the height of this rectangle is the height of the cylinder. The length of the rectangle, okay, if we cut it here and unroll it, the length, this would be one end, and go all around to the other end. If you unroll that, the length of that rectangle is the same as the perimeter or circumference of the circle. Okay. So to find that lateral surface area, to find the area of this rectangle, you have to do the circumference times the height. Okay, so this is circumference. This is the height of the prism. Okay, hopefully you can picture if I were to like flip up this circle and kind of roll this around it, this would go exactly around the perimeter of that circle. Okay. So perimeter times height translates into the circumference of the circle times the height of the prism, and then I add double the bases. All right, so let's try it with some numbers attached here. So here I have a circle that's 2. It doesn't tell me what the units are, that's fine. But it tells me the radius is 2 and the height of this is 6. So let's find the area of the bases first. Okay, so the bases are circles. Area of a circle is pi r squared. Okay, here it tells me the radius is 2. So pi times 2 squared. Well, 2 squared is 4. So I'm going to do 4 times pi, which is 3.14. Give me about 12.56. Okay. So that tells me the area of the base is 12.56. The area of the top circle is also 12.56. Okay, so I double that because there's 2 circles. Okay. For the lateral surface area around the outside, remember that'll give me a rectangle. The height of it is going to be 6. And the width of it is going to be the circumference. Okay, so you got to remember how to find the circumference of a circle. Well, the circumference is the diameter of the circle times pi. Okay, so if the radius is 2, the diameter is 4. So we got to do 4 times 3.14. That'll tell me the diameter, or tell me the circumference, which is how long that lateral surface area rectangle is, and then multiply that by the height. So again, 4 times 3.14 is 12.56. Multiply that by 6, and I get 75.36. Okay, so that is the area of the outside, all the way around the sides. Okay, so if I want to know the surface area, I just got to add those up. To get the total. Okay, so I add 12.56 times 2, and I get 100.48. So 100.48, it doesn't give me units, so I'm going to say units squared. That's my surface area. It doesn't tell you what the units are, you just say units. All right. Again, here's that net. All right, so I could have actually written it down here. So each of these circles is 12.56. Okay, and this is 75.36. All right, let's look at another one. So find the lateral surface area and the surface area of the cylinder. Okay. Again, I like to save the lateral surface area for last usually. I guess I'll do it first this time, just to mix things up a little bit. So the lateral surface area, that's the rectangle that goes along the outside. To get that, I multiply the height of the prism. Now, and be careful, the height isn't 5. Okay, the height is the height of it if it's sitting on the base. It's the distance between the bases. So the bases here are the circles. So this is tilted on its side. You got to think about tilting it back up. The height of the prism is 2 meters. Okay, and that's the distance between the bases. Okay, so it's 2 times the circumference. The circumference is pi times the diameter of the circle. It gives me the diameter is 5. So 5 times 3.14 gives me 15.7. Okay, multiply that by 2, and I get 31.4. Okay, so the lateral area is 31.4 meters squared, or square meters. Okay, if I want the total surface area, I got to add the area of the circles. Okay, so I'm getting a new pi r squared. It gives me the diameter, so I cut it in half. Radius is 2.5. I'm going to square that. So 2.5 squared is 6.25. Multiply that by 3.14. Gives me 19.625. Okay, so each one of these circles is 19.625. So to find the total surface area, I just take the 15.7 from the outside, and I'm going to add 19.625, double because there's 2 circles. So I double that number, add 15.7, and I get 54.95. So my total surface area is 54.95. Looks like it's measured in meters, so meters squared. All right, why don't you try this one? I'll pause the video when you got the answer. Hit resume and see if you got it right. All right, welcome back. Hopefully you got either 113 inches or 144.8 inches squared, depending on how carefully you read the question. Okay. So if we read the question carefully, it says, find the area of the label on the can of juice. So the label would go around the outside. You wouldn't have the label on the top and the bottom. So if you read that, it was really actually just asking for the area, the size, okay? So if we do that, we're doing the circumference of the circle is the width of that rectangle times the height, which is 8. So the circumference is the diameter 4.5 times 3.14, which is 14.13. Okay, we multiply that by the height, which is 8, we get 113.04. It says round to the nearest tenth, that would round down to 113 inches squared. Okay, if you didn't notice that, it was a little subtle, so not terribly surprised. You might have continued going. Let's make sure you did that correctly if you did. So if you continued going, you would have also added the area of the circles. Okay. Well, it gives me the diameter of 4.5, so I got to cut that in half first to get the radius of 2.25. And then I do the radius squared, which is this, times pi gives me this. Okay. So each circle is this 15.89625, but there's 2 circles, so I doubled it to get this. Okay, so the 2 circles together are right here, this 31.7925. If I add that on to the lateral surface area, the 113.04, and round out to the nearest tenth, I get 144.8. Okay, so if you got this, you did the math right. We just got to make sure we're reading the directions carefully. All right, if I look at this one would also have me just finding the lateral surface area. Okay. So when you think about rolling this roller, it's asking how many square inches does a single rotation cover. So the single rotation, that would just be once around the outside. So that would just be the area of the outside. Okay, so again, if I think about the cylinder, I just want the lateral surface area. Okay, so the circumference is the diameter 2 times 3.14. Then multiply that by the height of the prism, which here is 9, or the cylinder, sorry. If I do that, 9 times 3.14 times 2, I get 56.52. Okay, so if I look at my answers, it matches up with C. Okay, to the nearest tenth, how many square inches? Okay, so be careful what it's asking. Sometimes it'll just ask for the lateral surface area. In this case, it does ask for the total surface area, so I'm going to pause again. Let's see if you can figure this one out. Okay, hit resume when you're ready to check.
That on the corner, but you see that good run on that late just kind of came back.
All right, let's walk through this one together. So let's do the circles first. So area of the circle is pi r squared. Diameter is 6, which means the radius is 3. Okay, 3 squared is 9. Then multiply that by 3.14. I get 28.26. Okay, so each of the circles is 28.26. Okay, for the rectangle around the outside, I got the height is 8. The length of it is going to be the circumference of the circle, which is 6 times 3.14. Okay, so I'll do 6 times 3.14. It gives me 18.84 times 8 is 150.72. So there's the area around the outside. Okay, add the two circles to that. And I get 178.98. Did I make a mistake somewhere? Okay. So it doesn't match up exactly, but I'm guessing this one might have been rounded differently or used pi. Oops, I have found a mistake. Hopefully you spotted this too. It was not that. Okay, so let's see, what mistake did I make? Well, I did the area of the circle, but I only added it once. Okay, so each of the circles is 28.26. So I got to add another 28.26 onto here, which give me about 207.3. Okay, so I think I get 207.24 when I do this technically, which would round down to 207.2, but I'm guessing they used pi instead of 3.14 for this answer, which is why it's slightly higher. Okay. All right, so last question. We got two possible designs for a cereal box. We want to know which would take less material to make. If you are running a factory, you got to pay for the cardboard that makes these boxes. Having a design that uses up less material is going to save you money. So you want to figure out which of these takes less material to make. So that would be the surface area. So find the surface area of these two shapes, see which is the better design in terms of using less material. All right, I'll give you a minute to figure it out, and then we'll see if you were correct. All right, welcome back. Hopefully you got that the box is less material. It's a lot less material. Okay, so we do this one. Got to find the area of two circles. So we got 5 squared times 3.14 is 78.5. So that's what each circle is. Around the outside, that's the circumference of the circle. It should be 10 times 3.14 times the height, which is another 10. Gives me 314. Add them all up, you get 471. For the rectangular prism, you just have 5 times 4 for the top and bottom. So you double that. That's 20, 20, and 20 is 40. The sides are 5 by 6. The 30 and 30 is 60. Front and back, those are 4 by 6, which is, I'm sorry, side and side. 4 by 6 is 24. Double that, you get 48. Out of those up, you get 148. So this would be the much cheaper design to make. It's also a lot smaller, but you might get how this might be used to compare how much it holds versus how much it costs to make. Okay? Now, how much it holds is going to be based on volume, which we're going to learn about tomorrow. But tomorrow, you have the skills to compare not only what their material, how much material they take to make, but also how much they hold in order to figure out what is the better way to make a box. All right. Good luck. Let me know if you have questions.